Expected value, fair games. If x is a discrete random variable that represents the gain of a player, then if e of x is 0, the game is fair. In other words, the player doesn't win anything but doesn't lose anything. Example 1. In a simple fair game, a card is picked from a full pack. Ace of spades wins $40. Ace of diamonds wins $10. Ace of hearts wins $2. All other cards lose. The cost of a go is $1. Is the game fair? First thing you need to do is draw yourself a probability density function table. In this game, you can win $40, $20, $2, or nothing. The probability of winning $40 is 1 out of 52. The probability of winning $20 is 1 out of 52. The probability of winning $2 is 1 out of 52. The probability of winning nothing is all that's left, 49 out of 52. In order to work out whether the game is fair, you need to work out the expected value, which tells you on average how much you will win for every go of the game. So the expected value in this case is 40 times 1 out of 52 plus 20 times 1 out of 52 plus 2 times 1 out of 52 plus 0 times 49 out of 52, which when you work it out comes to 1. But we have not taken into account the cost of the game, so we need to subtract 1. So the expected value is 1 minus the $1, which equals 0. Therefore, because the expected value is 0, the game is fair. There will be no winners and no losers on average. Example 2. Some students are designing a dice game as part of a CAS project. The only thing left from a meeting is an incomplete table and the fact that the expected value was 67 out of 20. They also know that f of x is linear. A. Find the missing values. B. Decide what to charge to make a small profit. Let the two missing values be A and B. We know from a probability distribution function that the probabilities add up to 1. Therefore, 11 over 40 plus a quarter plus A plus B plus 1/8 equals 1. Therefore, when you rearrange this, you get A plus B is 7 out of 20. We also know that the expected value of x is equal to 67 out of 20. Therefore, we know that 1 times 11 out of 40 plus 2 times 1/4 plus 4 times A plus 6 times B plus 7 times 1/8 equals 67 out of 20. Therefore, when we expand and rearrange, we get 4A plus 6B equals 17 out of 10. So we have two equations and two unknowns, so they can be solved simultaneously using a GDC, giving A equals 1/5 and B equals 3/20. B. The expected value is 67 out of 20, which equals $3.35. That means the players on average win every go, $3.35. So if the students want to make a slight profit, they need to charge each go more than $3.35. So maybe they should charge $3.50 or $4. Finding f of x. We're told that f of x is linear. From the PDF table, we know when x is 1, f of x equals 11 out of 40. Therefore, using y minus y1 equals mx minus x1, we can find the linear equation. We know that m is equal to y2 minus y1 divided by x2 minus x1. Therefore, 1/4 minus 11/40 divided by 2 minus 1, which when you work it out comes to minus 1/40. Therefore, substituting everything in, we get y minus 11/40 equals minus 1/40 brackets x minus 1. Therefore, y minus 11/40 equals minus 1/40x plus 1/40. Therefore, that will rearrange to y equals minus 1/40x plus 12/40. Therefore, f of x can be written as 1/40 brackets 12 minus x, which is the probability density function.